Good morning, welcome to the Lionhearted Academy. This is Richard Tai. We're continuing our trigonometry lessons. Today we're starting a new topic, one of the last major topics that we're going to be going through throughout our series, which is the topic of solving oblique triangles. Okay. Now, a lot of you know this topic's different curriculums, different textbooks call it by different names, but I felt that this is what we're doing because this is the purpose of using laws of sine and laws of cosine. So we're talking about solving oblique triangles. This is I believe this is more descriptive of what we're actually doing here. It's because we're solving the triangles and we're using different rules and laws to help us. Now, what is an oblique triangle? An oblique triangle is a triangle that does not contain a right angle. So is a triangle does not contain a right angle. So we have been working with right angles or triangles with right angles most of the time since the beginning when we learn geometry, when we learn right triangle trigonometry. But the trigonometry can be extended to triangles beyond right triangles. So oblique triangles, it can be acute, it can be obtuse, okay, but it cannot be right, okay. So in terms of angle classifications of a triangle, it can be acute, okay, it can be acute or obtuse. Alright, so those are the triangles that we'll be looking at instead of a right triangle. And what do we mean by solving an oblique triangle? Well, to solve an oblique triangle, in general, we did solving right triangles before. Now we're solving oblique triangle. To solve a right triangle means to find the measure of every angle and every side. So in order to solve a right triangle, solve a triangle, okay, not a right triangle, any kind of triangle, it means to find the measure of every angle and every side. That's what that it means. So however, usually we have to, so there are actually 6 parts out in any triangle, right? We have 3 angles and 3 sides. So in order to solve a triangle, in order for us to find the measure of every angle, every side, we need 3 parts. We need 3 parts, okay, before we can solve an oblique triangle, okay? Oblique triangle. We need 3 parts out of the 6 in order to solve the oblique triangles, okay? However, what kind of information is given to us depends, really will determine what kind of solutions, what kind of methods that we will proceed, alright? So, let's go ahead and break it down into 4 possible cases. So there are 4 possible cases. We're going to be talking about the possible cases. So first case, case 1, is that we are given 2 sides. I'm sorry, 1 side and 2 angles. We're given 1 side and 2 angles. 1 side and 2 angles. So any 2 angles in a triangle, and then there was the side. That's any 1 side that's considered this case. Alright, so let me go ahead and show you, for example. Okay. Alright, so I'm just going to draw a triangle. Okay, I'm just going to draw a triangle a little bit differently here. Yeah, so this way. Now, usually we use triangle ABC to indicate our triangle here, and so A, B, and C indicates the angle A, B, and C, and then the opposite side we use lowercase a and lowercase b and lowercase c, so we know which side is opposite to which angle. using this method of the notation. So if we're given one side and two angles, we can be given angle A, angle B, and side C. That means it's two angles with one side in between them, or it can be angle A, angle B, and side A. That means we have given two angles and the side opposite to one of angles, or we can give an angle B, angle A, angle B, and side B. Okay, so two angles and then the side opposite one of them. So given one side, two angles, there can be two situations: angle, side, angle, which is the sides between the two angles, or angle, angle, side. That means the side given is opposite to the angles. Alright, so given two angles and the side opposite them or in between them. So both of those are called case 2, case 1. Now in case 2, we're going to be given two sides and angle opposite one of them. So it's given two sides and an angle opposite one of them. Alright, so for example, if I'm given side little a and side little b here, and then I'm given the angle A or angle B, that would be case 2. If I'm given side B and side C, and I'm given angle C or angle B, then that's case 2. Alright, because if I'm given two sides, A and C, and I'm given angle A or angle C, that's case 2. But if I'm given angle A and angle C, side A and side C, then I'm given angle B. Angle B is in between the two sides, so that's not what we want in case 2. That's not case 2. So case 2 is side, side, angle. Side, side, angle. Okay, side, side, angle. So it's the angle opposite to two sides. You have two sides and then you have angle opposite to one of them. Now this is a special case because case 2 is a little bit more complicated than case 1. So we'll deal with that when we comes. And then let's talk about two more cases. Case 3. Okay. Now in case 3, we are given two sides and an included angle. So given two sides and the included angle. That means the angle is in between the two sides. So if I'm given side C, side B, I have to given side angle A. So side C, side B, angle A, that's side angle side. So this is called side angle side case. Alright? Or angle C, side A, angle C, side B, that's side angle side. Okay? Alright, last case, case 4, is given three sides. Given the three sides, okay, which is side, side, side. Now notice, there's no given three angles. Angle, angle, angle. There's no such case because given the angles A, B, and C, there are infinite number of solutions we can put in there. Because given the angles only without giving any of the sides, that does not tell us anything about the triangle. We can construct different kinds of triangles, infinite number of triangles based on the different combinations of lengths of sides using the same angle. So angle, angle, angle would not be a valid information in order for us to solve oblique triangles. Okay, so in order to solve oblique triangles, we have to have, in this situation, angle, side, angle, 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 side, which is case 1, one side and two angles, or two sides and one angle opposite them, side, side, angle, or two sides and the including angle, side, or given three sides, side, side, side. Okay, so let's go ahead and start talking about case 1. Okay, and case 1 and case 2, what we're going to do is we're going to use the law of sines to solve. In case 3 and case 4, we're going to use the law of cosines to solve. Okay, so we're going to start with case 1 and case 2. And case 2 is a little bit complicated, so we probably will spend the whole lesson doing that. But today we can definitely go ahead and just talk about case 1. Alright? Alright, so case 1, go ahead and draw a triangle again. I'm going to draw a scaling triangle, oblique and scaling triangle. Again, our indication, our notation for angles will be capital letters A, B, and C, and the sides will be opposite to angle A will be lowercase a, opposite to the angle B will lowercase b, opposite of angle C would be lowercase c, so that we will understand how to go ahead and solve this. Okay, so let's develop this solution first. So actually, let me take it back. Let me go ahead and bring the triangle to the forefront here, so that okay, I'm sorry, let me go ahead and do this a little better. Okay, I would like to alright, okay, so let's take a look at this. So this is angle A, angle B, angle C. So this is side A, this is side B, this is side C, excuse me, and side B. Okay. Well, actually, I'm sorry, I do apologize. Let's go ahead and use this as angle C, and this is angle B. Okay. So I would like my side B here and the side C here. All right. So let's take a look at this triangle. Let's say let's go ahead and draw the height. Okay, the altitude, the height. This is the height of the triangle, right? Okay, so let's call that H, the height of the triangle H. Okay, so let this H be the altitude from angle C to side C. So let's take a look at angle A here. What is the angle A? How do I represent angle A in terms of H and B? Well, this is a right triangle, is it? Because the height is perpendicular to the base here. Okay, so H is perpendicular to the side C, and so this is a right triangle. And angle A, consider angle A, H is the opposite side, B is the hypotenuse. So sine of angle A is equal to H over B. Is that correct? Which is true. Okay. Now, what about angle B? Angle B, if you look at this triangle, this right triangle, this part, okay, for angle B, H is the opposite side, but A is the hypotenuse. So sine of angle B would be equal to H over A. Okay, but H is the same H, so that means H is equal to B times sine A. But H here is also equal to A times sine angle B. Alright, so because they are the same, so I can equate them. B equal to B times sine A equal to A times sine B. So that means I can come up with a proportion here. I can divide both sides, kind of like cross multiply and divide both sides by sine B and divide both sides by sine A. So I would have basically B divided by sine B is equal to A divided by sine A. So this is a basics for the law of cosine. This is the basis for the law of cosine. And I can further show you that if I go ahead and draw the altitude from A to C, from angle A to side A, I'll be able to prove C over sine C is equal to A over sine A. So the law of cosine here, so the law of sine, okay, I'm sorry, I say cosine, law of sines is this. Is any triangle, in any oblique triangle, A over sine A is equal to side B over sine angle B is equal to sine C over sine angle C. Now those angles are their opposite angles. Okay, so basically the proportion of the side to its opposite the side to the sine of this opposite angle is equal throughout the triangle. Okay, so this works not just in oblique triangles, it works in any triangles. Alright, so based on this fact, we can go ahead and solve case 1. Okay, so now let's go ahead and do case 1. Case 1 is angle, side, or angle, side, angles. Two angles, one side. Case 1 is one side and two angles. Okay, one side and two angles. Alright, so let's draw a triangle here to show you how to use it. Alright, let's go ahead and finish this up. Alright, so let's go ahead and do an example here. A, let's do C here and B here. Alright, side A, side B, and side C. Alright, so example 1. Let's given, okay, angle A, let's just make up a 34 degrees. Angle C is 79 degrees, okay. And then let's do angle side. So let's do side A equal to 12 inches. Alright. So this is angle A is 34 degrees. So let's go ahead and put those information on this triangle. So this guy is 34 degrees. This guy is 79 degrees. Angle C, and side A is 12 inches. Alright, so then let's go ahead and see how we can solve other. The first thing is I can solve for angle B by using the fact that all the sum of interior angles of a triangle equal to 180 degrees. So measurement angle B will simply equal to 180 minus 34 and minus 79. Alright, so that will simply become 67 degrees. Okay, so that's measurement angle B. So we got this 67 degrees. I put it in red, so that indicates that's the information we solved. Okay, now we have two more sides that we need to solve side B and side C. Now if you remember the rule that we had before for law of sine, excuse me. Okay, law of sine looks like this. So we want to solve for, we can use B over sine B equal to A over sine A. Now why do I use A over sine A? Because we do know side A. Side A is given to us 12 inches. So in order to solve for side B, I have to multiply both sides by sine B. So it's A times sine B divided by sine A. Alright, at this point, let's just go ahead and plug them in, substitute the information here. So A is 12 inches, sine B is 67 degrees, sine A is sine of 34 degrees. Alright. So make sure your calculator is in degree mode here. We're using degrees. 34. So divide that, multiply by 12, and you will get about 19.75 inches. I rounded off to the hundredths. So B is about 19.75 inches. Okay, so 19.75 inches. Then we go ahead and solve for side C. We use the same thing. C over sine C is equal to A over sine A. Now in this case, you could use angle B, use side B over sine B, but I prefer to use the given. The reason is when you use the given information, it is more accurate, and so you don't have to create rounding errors. So here, let's go ahead and plug in, substitute information. So A is 12 inches, sine angle C. Angle C was 79 degrees, and angle A was 34 degrees. So you go ahead, plug this in. 12 times sine of 79 divided by sine of 34. So make sure you're in degree mode. So this will become 21.07 inches. Okay, 21.007 inches. So this becomes 21.07 inches. Alright, so we are done. We have solved case 1 by using angle side or angle side angle. Now we didn't do the angle side angle, but it's the same process. First, you solve for the missing angle by using the fact that all three angles add up to 180 degrees, the internal angles add up to 180 degrees. After that, all you have to do is use the law of sine, use proportion, basically use proportion to solve for the missing sides. There will be two missing sides, and you can go ahead and solve for the two missing sides. Alright. Now, there is one way to check the solutions, because how do we know if we did it right or did it wrong? There's a way to check the solutions, but I think we'll go ahead and talk about that tomorrow. Okay, we'll talk about that in our next lesson. How to check solutions. There's a certain rule, there's a certain formula, Mollweide's formula, okay, Mollweide's formula that we can use to check for the solutions. Actually, let me just go ahead and give you the formula right now, okay. This is called Mollweide, I'm sorry, Mollweide, Mollweide's formula. Formulas to check the solutions, because this way we will be able to ascertain what we got is actually true. Alright, so in any triangle ABC, it always will work. Sine A minus sine B over sine C. This proportion will be equal to sine of angle A minus angle B divided by 2 divided by cosine of angle C divided by 2. So this is one way to check it. Or if we do A plus B over C will be equal to cosine of angle A minus angle B divided by 2 divided by sine of angle C divided by 2. So these two formulas will allow us to confirm the angle measurements that we got and the sine measurements we got actually works for a right triangle. Okay, for any triangle. It doesn't have to be a right triangle. It can be oblique triangle. It can be right triangle. It will always work. So using these two formulas, we will be able to check for sure that what we got is right. Because later on, in case 2, we will have situations where there are no solutions. So if you come up with an answer, you might be able to come up with an answer, but the answer will not be correct. Okay, so this is something we'll go ahead and talk about next time. Next time, we'll go ahead and focus on our case 2. So if you have any questions on today's case 1 or on the law of sine, please go ahead and leave your questions in the comment sections. We hope you see you next time.